Hello everyone, I'm Bingja. Welcome back to another video. So in this video, it's going to be the second video of chapter 6 and where we are going to be talking about trigonometry. So in this video, I believe it will be a particularly short one because in this video, I'm just going to be introducing you about the, it's not, the graphs. Alright, the graphs of sine, cos, and tangent. Alright, so this is something that you will need to know so that once you see this kind of graph, that's a sine graph and so on. So you need to identify the graphs. Alright, so number two, I will be introducing to you how to solve simple trigonometry. Alright, it's just like a little bit of example that I did from the last video, and plus I'm going to introduce to you how to solve simple trigo where it's kind of like an identity. Alright, so we will see in this video because that is more like an add maths thing than a maths one, but I'm not sure whether you learn this in maths, so I'm just gonna introduce it to you in this video first. Alright, so let's go. The first one I'm going to start with is the sine graph. Alright, so sine graph right here, number one, sine graph, sine x graph. Alright, okay, never mind. Y equals to sine x graph. Alright, so this is the y-axis and this is the x-axis. Alright, for the y equals to sine x graph from 0 to x to 360 degrees. Alright, so this is the typical one. Alright, so how does the sine graph looks like? Okay, so the sine graph looks something like a wave. I know it's ugly, but let me draw it. I still don't like this actually. No, okay, never mind. Go up, go down, come back up. Okay, so this is the normal sine graph. Okay, and I'm going to extend this a little bit. All right, so the top value here is 1 and the bottom value here is -1, and this is the origin 0. All right, so one important thing for you to sketch the sine graph is you must sketch the graph only you can name the angles. All right, because the angles must be almost the same distance. All right, so this is a little bit different than the other sketches. Okay, so this thing right here is 90 degrees. All right, and then and this angle right here is 180 degrees, and this angle right here is 270 degrees. Last but not least, this is 360 degrees. Okay, so from this graph right here, you can see the sine graph starts from 0. All right, when x equals 0, y is equals to 0. It moves up until y is equals to 1 and x is equals to 90 degrees, and it goes back down. All right, and it touches the x-axis in 180 degrees. Then it moves down and goes back up. All right, so beyond 360 degrees, it will be repeating the same thing over and over again. So this is the sine x graph. Okay, so some easy things here to take note of is I think I'm gonna write here. So from the graph, you can see that sine 0 is equals to 0. All right, wait, sine, maybe I'll just write it down there. Okay, I'll write it here. All right, so sine 0 degrees is equals to sine 180 degrees and is equals to sine 360 degrees is equals to 0. All right, this is the number one. Number two is sine 90 degrees is equals to 1. All right, and last but not least, sine 270 degrees is -1. All right, so this is the simple properties of a sine graph. So when you see an upward wavy line, all right, then you know this is a sine graph. Number two, right here we have got, I'm going to introduce to you the cosine graph. All right, cosine graph. or I can say it's y is equals to cos x graph. All right, so to draw the axis, the axis goes like this, y, and x. All right, so the cos graph is obviously different than the sine graph. It starts from 1, goes down, comes up. All right, so this is not a nice one. Okay, so this is the best I can attempt here. You can Google search cos graph for more, but this is somehow like the cos graph that you will get. All right, so this is still 1, and this is -1. Okay, and to mention it right up here, okay, it's y equals to cos x graph, where it goes from 0 to 360 degrees. All right, so in maths, we are usually just gonna see from 0 up to 360 degrees. Okay, so where we go down here and we are to name all these with this, and this is 0, and cos graph is 0 at 90 degrees, and this is -1 at -1 at 180 degrees and 270 degrees, and this right here is 360 degrees. Okay, so from the cos graph, we can you can see it's like a quadratic curve, but you can't actually draw it like a quadratic curve. You must include a little bit of a curving down at the front and at the back. All right, so it's a little bit different than the quadratic curve. So what can we analyze from this graph is, we know that number one, cos 90 degrees is equals to cos 270 degrees, which is equals to 0. All right. Second, cos 0 is equals to cos 360 degrees is equals to 1. And last but not least, you have cos 180 degrees is equals to -1. All right. So yeah, these are the properties of a cos graph. Okay, jumps by 90 degrees from 1 to 0 to -1 to 0 back to 1. All right, so these are the properties of sine and cosine graph. All right, so next we are gonna move on to the tangent graph. Okay, so number 3, y is equals to tangent x graph, where the domain is from 0 all the way up to 360 degrees. All right, so this is a little bit hard. I mean, it's not hard, it's very special, all right, as compared to sine and cosine. All right, so there's something to take note here. This is y and this is x. Yeah, and this is x. So the tangent graph will look something like this. All right, and then there's an asymptote. All right, and it goes something like this, another asymptote, and goes up like this. Yeah, so this is the tangent graph, correct. So how do you label a tangent graph is, we label it, the half right here is 45 degrees and it's 1. All right, so this is how you show it's a tangent graph. And what are the asymptotes? All right, the asymptotes is 90 degrees and 270 degrees. All right, so these are the asymptotes where if you type it inside your calculator, all right, tangent 90, you will get something like a math error. All right, so it goes the same to tangent 270. All right, so tangent is 0 when it's 180 degrees and 360 degrees and of course 0 degrees. All right, so yeah, this is like the basic tangent graph, and there is not really a lot of things you can remember here. So if we are going to write down, number 1, tangent 0 degrees is equals to tangent 180 degrees is equals to tangent 360 degrees equals to 0. All right, and this is very similar to sine graph. As you can see, sine 0 is equals to sine 180 equals to sine 360 degrees. Okay, Number 2 right here, we have the tangent one, sorry, yeah, it's the asymptote. Asymptote at tangent 90 degrees and tangent 270 degrees. So asymptote is when the graph is gonna move parallel to the asymptote when it's very short. So it will never intersect. All right, from here it will be very, very high and this will be very, very low. Okay, so this is the basic for a tangent graph. And yeah, these are the 3 graphs that you will need to know. So when you see something like this wavy one, it will be sine graph. A bell, inverse bell, all right, then it will be a cos graph. And this graph here with 2 asymptotes is going to be a tangent graph. All right, so to the next part here, actually I covered this a little bit from the last video, all right, where we are going to solve some simple quadratic equations. And the example given is to solve sine x is equals to sine 3 over 2. All right, there are 2 methods, okay, for this. Method 1, all right, is using the calculator. I know where the calculate word went wrong from the previous video. Yeah, okay, now I found out. All right, so method 1, you use the calculator where you will find x is equals to inverse sine 3 over 2. All right, where you will get 60 degrees. Okay, and method 2 is to work it out. All right, so it's by using the properties of triangle. All right, so this is more of an math stuff. I'm not sure whether it will be covered in maths, but I will be covering it in this video. So next time when I'm covering maths, I will just direct it back to this video. So that as you can see, why do I know inverse sine is 3 over 2 is equals to 60 degrees that fast? All right, so we'll go on method 1 first. So using the calculator, all right, press the shift, press the sign, all right, and then sut is this square root right here, 3 divide 2. Okay, close the bracket, press the equals, you will get 60 degrees. Okay, so method number 2 is using the properties of triangle so that we can actually know a little bit of sine, cos, tangent with some answers right there. All right, so I'm going to explain this to you. How can you actually know the answer real quick? Okay, so consider this as an equilateral triangle. Does it look like an equilateral triangle to you? Okay, assume this is an equilateral triangle, all right, with length 2, all right, and here I'm going to divide this into half so that this is 1 and this is 1. All right, we all know an equilateral triangle has the angle 60 at all sides. All right, so this is going to be 60 and this is going to be 60 and this is going to be 30. All right, so from this triangle right here and using Pythagoras theorem, we can find out that x is equals to 4 minus 1, all right, which is equals to 3. Okay, therefore this height in between is going to be 3. Okay, and this is right angle. So in this diagram, what can we show? All right, using the cas sautoir that I have introduced to you, we can actually find out that a lot of angle properties right here. So number 1, all right, it's the 60. Okay, so sine 60, or I should change a way of writing it. Okay, so I can save more spaces. Okay, I'm gonna draw a table. Okay, So in this table right here, I'm gonna use the black color. All right, so table, what's happening? Okay, so I'm gonna write down here sine, cos, and tangent. All right, and this is going to be 30 degrees and 60 degrees. All right, so how do you read this table? All right, so first thing first, we are going to look for sine 30. So 30 is right here. All right, and by using the, where can I write this? By using the rule where it says sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, and tangent is equals to opposite over adjacent. All right, so by using this casse-au-trois, we can know that sine 30 is equals to opposite over hypotenuse. Therefore, we know that this sine 30 is 1 over 2. All right, and sine 60 is the same. So sine 60 is equals to opposite, which is sub 3, over hypotenuse, over 2. Therefore, you know this sine 30 will be equals to sub 3 over 2. So sine 60 will be equals to sub 3 over 2. Okay, so this is going to be sub 3 over 2. All right, and using the same diagram above, you can get a lot the same thing right here. All right, for cos, and then for tangent too. All right, so tangent is equals to opposite over adjacent. So tangent 60 is equals to opposite over adjacent. So tangent 60 is just going to be sub 3. All right, and tangent 30. All right, tangent 30 is equals to opposite over adjacent. All right, so it's 1 over sub 3. Okay, 1 over sub 3. Or if you want to rationalize it, it's going to be sub 3 over 3. All right, but I doubt you will learn rationalization in mathematics. Okay, so this is the simple diagram for working on 30 and 60. And next, this last triangle right here, it's going to be a isosceles triangle. Okay, so this is going to be an isosceles triangle. All right. Okay, so these two have the same length. Okay, I'll just name it 1, 1. Okay, so if I'm going to draw a line in the middle, all right, and then I will break this into half, all right, and this right here, let's say all right, so this is going to be an isosceles triangle, all right, where these two have the same length. Okay, and now I'm going to and this little thing right here is very hard to, okay, great. So now I'm just gonna redraw it. Okay, and the next thing here we're gonna draw is an isosceles triangle. Right, it's a little bit difficult to draw a triangle. Okay, so same thing, it's the isosceles, these two have the same length. All right, and then when I divide this into half, all right, assume these two have the same length. All right, so if we assume these two have the same length and both of them have length 1, okay, So this is 1 and this is 1. Okay, so by Pythagoras, we know that this is sec 2. And from an isosceles triangle, we know this is 45 degrees and this is also 45 degrees. All right, and this is a right angle here. Okay, if we cut the half. So same thing, for 45 degrees, we can use the rules of Ka, So, and Toa. All right, to look for these three information down here. Number one, sine 45 will be equals to cos 45, which is 1 over sec 2. All right, if you want to rationalize it, is sec 2 over 2. And then number 2, from here, you can find out that tangent 45 will be equals to 1. All right, therefore, you can see when I sketch the tangent graph, it's very important for you to label at the 45 degrees, it's 1. All right, so this is the simple that you can derive it. I mean, from things that you can derive from this isosceles triangle and this equilateral triangle right here. Okay, so yeah, this marks the end of this video. I believe that it's actually long as compared to what I said it should be short. So yeah, I hope you guys understand everything about this video. So I have introduced to you sine cos tangent graph and how to solve simple sine cos tangent. Like I can say sine x is equals to 1 over 2. Then you know x is 30 degrees real quick. If you remember these two diagrams, okay, there's nothing much to memorize actually. You just need to know equilateral triangle, divide into half. One is 30, one is 60. Then you can just find your cos or toa from there. All right. Yeah. So hope you guys enjoy this. I'll see you guys next time. Thank you.